So, geometry students, we're going to do the review for the big quiz. Just like you to notice, there is a particular emphasis on this type of triangle inside of a triangle that will be on your big quiz, but maybe was not on your previous materials. So, if you were going to focus on understanding something that might be a little bit new, it would be these triangles. Okay. But I'm going to go from start to finish. We have a smaller football field, a model of a football field that is 5 1/3 inches and 90 inches. And I'm going to create an actual football field, which is going to be bigger. This is maybe the idea of our bigger football field, though it doesn't look bigger. And we can see that the ratio is like 1 inch to 30 yards. So like I'm going to take my inches and multiply it by 30 to get my yards. And if you have a calculator, you could do that. And this will allow us to be able to check all of our work, to have all the dimensions that we need. And I would love to see if my calculator would turn on. Let me try again. And there it is. So we got 5 1/3. What is 5 1/3? Well, you can do 5 plus a third. You could do 5 is 15 thirds plus a third is 16 thirds. Cool. Taking that and multiplying it by 30, and you get 160 yards. And then we'll take our 90 and multiply it by 30. We get the actual football field is 2,700 yards. Not sure if this is accurate. Maybe it'd be better if this was feet, but whatever. Huge football field. All right, cool. So there's the length and the width. What's the perimeter of the actual football field? Now, I'm going to show you how we could have done this without even knowing these dimensions, but we're going to be able to check it. So let's go and find the perimeter of the model by taking 2 of my 16 thirds. Doubling that, then adding 2 of my 90s. And you get that the perimeter of your model is 190.667. Well, you know that the perimeter of your actual, since perimeter is just a length, that you could take your perimeter of your model and multiply it by 30. So I'm going to do that. Just take the perimeter of my model and multiply it by 30. And we get 5,720. And we're going to assume that your calculator is just off by a little. Now we can double check this by having the actual dimensions and calculating it that way. So just showing you the two ways you could do things. Sorry, 160 times 2 plus 2,700 times 2. And you get that same number. Cool. Now, what about the area? Well, this is where, and this is the last lesson, if you found the area of your model, which would be 5 1/3 times 90, I'll just write 16/3 times 90. 3,480 square inches. You could get the area of the actual field by doing what? Taking the area of the model and multiplying it by 30? No. Areas in units squared. So this times 30 is like a length factor. It's a scale factor. But I would actually take this area of the model and multiply it by 30 squared, the length, the units squared. So let's see that. 3480. It's 4 twice. Times parentheses 30 squared. Okay. Huge number. Well, 3132,000. Okay, well, let's see. Could you have actually used the dimensions 160 by 2700? Multiply those together, and I got something different. What the heck happened? I feel like the area of my model is way off. Hold on. Yeah, I did not type in 16/3. You probably caught that. I was doing it. I should have noticed that number seemed off. My apologies. 16/3 times 90 is 480. Whoops. 480 times 30 squared is 43,200. And that is the same as if I had my dimensions of my actual fields and I just calculated this area. Okay, so again, you got to understand the relationship between the model and the actual. This is very important for your quiz, guys, because we will be giving you an object where you're not going to be able to find all the dimensions. We're just going to say, hey, the perimeter of the smaller object is this. What's the perimeter of the larger object? And you won't be able to calculate it. It'll say, hey, the area of the smaller object is this. What's the area of the bigger object? Or vice versa. So you have to understand the relationships between them. Okay, we have two triangles. We have an equilateral that is 8 centimeters big on each side, and then we have an equilateral that is 4 centimeters big on each side. What is the ratio? Well, like you double the smaller one to get the bigger one. So the lengths will be doubled. You could say it's 2 to 1. You could say it's 2 to 1. You could say it's just times 2. It's fine. What about the areas? Well, if the lengths are doubled and the areas are, squared units, the areas will be multiplied by 4, which is 2 squared. Say it's 4 to 1. You could say 4 over 1. You could say 4 to 1. That would be the ratio of the areas. What is the area of the first triangle? This is actually not so super important for this unit. This is more important for next unit. We'll be doing it more. If I drop down a height, I know this base length is 8. Well, this would be half of that, which is 4. And you can use the Pythagorean theorem 4 squared plus b squared equals 8 squared, and you'd be able to find that b squared is 64 minus 16, which is 48. And that is going to be b root 48, which I can simplify to be root 4 root 12, which is actually root 16 root 3. And I realize b is 4 root 3. So this is 4 root 3, but maybe it's easier to use root 48 in your calculations. The area of the first triangle would be 1/2 my base length times my height. Now this is easy enough to do. You'd get 16 root 3. But if you have a calculator, you can do the calculations and get decimals. I'm just going to go ahead and know that the area of the second triangle, the shorter triangle, I will divide by 4. So dividing by 4, I'll get 4 root 3. I don't even have to do the calculations to get that. I can just say, take this area and divide it by our scale factor squared. If you wanted to do it, you could. This would be 2. This would be 2 root 3. And you'd have 1/2 your entire base length of 4 times your height of 2 root 3. And look at that, you got 4 root 3. Cool. Now we get to kind of like the newer triangles. We have a triangle inside of a triangle. Here is the key. You need to be ready for this, for your quiz. You have one smaller triangle that is similar to the bigger triangle that it's inside. Okay, and we're going to kind of draw those again, just so we understand their relationships. But before we do that, let's kind of label everything that we have. We have BD is 4. We have BE is 5. We have CE, which is 2. Okay, cool. So like we labeled things and we're trying to determine the length of AD. So AD, I'm just going to say this is X. Well, what are the two triangles? What is the smaller triangle? And what is the bigger triangle? And what are the lengths? Well, we have the smaller triangle DBE, and then we have the bigger triangle ABC. The smaller triangle has a length of 4 and a 5. The bigger triangle, let's think about it, from B all the way to C would be not 2, but 5 plus 2, which is 7. B to A is not X, but X plus 4. And this is very, very important. You kind of seeing this. Now, if you'd like to, if you're a proportion person, you could set up a proportion. You could like cross multiply and solve. Or if you're more of like a scale, how many times bigger is this one? You could take the number 7 divided by 5 to find the scale factor. You get 1.4. So you're like, okay, this triangle is 1.4 times bigger than this triangle. And how can you use that? Well, you know that 4 times 1.4 has to equal X plus 4. Or you could say X plus 4 divided by 1.4. Look how easy this is. You get 1 equals X plus 4. You get X has to equal -3. Wait, what happened? Oh, not 1/4. 1.4. What am I doing? 4, this value 4 times 1.4 has to equal X plus 4. 4 times 1.4 is 5.6. Subtract 4, we get X equals 1.6. So that means this would be 5.6, and that works out well. If you're not comfortable doing it that way, here's an or. You could set up a proportion. You could say like bigger to smaller equals bigger to smaller, or vice versa. You could cross multiply and divide. Just when you multiply by 5 here, you get 5x plus 20, and then you subtract 20, you divide by 5, you get 8/5. Guess what? 8/5 is the same as 1.6. Same answer. Okay. So, your turn. Start by understanding the two similar triangles, then labeling the lengths, then like drawing the triangles separately so you understand the lengths. We got DE is 8.3. We got AC is 12.4. We have AD is 3. We're trying to find the length of BD, which must be X. Okay, this one is going to be a little bit trickier, team. Let's see if you can figure it out. We have the smaller triangle and the bigger triangle. The smaller triangle is DBE again. It's a B, not a 13. The bigger triangle is ABC. We have this bigger triangle length is 12.4. The smaller triangle length is X plus 3. We have BD, which is X. Sorry, 8.3. BD, which is X. BA is X plus 3. Okay. What could you do? Two things. Set up a proportion, cross multiply and solve, or let's kind of figure out the scale factor and use that. Well, like if these are similar triangles, how many times bigger is 12.4 to 8.3? How do you figure out how many times bigger something is? You divide. So let's do 12.4 divided by 8.3. And you realize that this triangle is 1.49 dot dot dot. There's a lot more decimals in there. I'm just going to keep this like as a placeholder times bigger. Don't round in this class until you get your final answer. Like keep it like that. And how can we use that to our advantage? Well, this length X times 1.49 with the rest has to equal X plus 3. This is one way you could do it. 1.49 X's has to equal X plus 3. Okay, so it's like this times 1.49 has to equal that. Well, this is an amount of X's. I can subtract 1x from this amount of X's, and I get this number minus 1, which is that number, 0.49 dot 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 X's equals 3. How do we find X? We're going to divide by that 0.49 dot 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 number. So 3 divided by that 0.49 dot 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 number. You just like go up and like press enter and you can select it if you have a calculator. You really need a calculator for this. But I'll show you if you don't have a calculator, I can you leave your answer in a calculator ready form. 6.073 dot dot dot. Let's do calculator ready form. Okay. So let's go with calculator ready. Same idea. Well, how many times bigger is this triangle compared to this? 12.4 over 8.3 times bigger. You could do, I don't know if you're going to like this. You could do X times 12.4 over 8.3 equals X plus 3. You can then subtract 1X and you're like, well, I have 12.4 over 8.3 minus 1 X's equals 3. And then you can get X is 3 divided by this number. You probably don't like that. I don't either. Your quiz is going to have nicer numbers. How about that? The other way to do this is to set up a proportion. Bigger to smaller equals bigger to smaller. And cross multiply and divide. This is 24.9. Don't divide yet. Subtract the amount of X's. And you get 24.9 equals, this will be 4.1 X's. If I take 24.9 and divide it by 4.1, I'll get the answer. And that is actually very much a calculator ready form. It's great also. Okay. Um, this is just kind of like review. It's not really similar triangles. I don't want you to stress about this problem. It is not something that you need to worry about on the quiz. Uh, you have this is 100. This is 50. What is this? You just use the Pythagorean theorem. 50 squared plus 100 squared equals c squared. And you get your answer. Whatever this is. Cool. After another 5 seconds has passed, what happens? Well, if you're rising at 10 feet per second and 5 seconds are passed, you have another 50. So this is 100. So you have um, 100 squared plus 100 squared equals c squared. And then c is going to be 2 root 100. Or, yeah, 2 root 100. No, 100 root 2. Because you have 100 squares. And if you square root, you get 100. Again, not important. Just review. Okay, cool. This, again, triangle inside of a triangle is important. This idea of Stephanie casting a shadow is important. We have Stephanie, who's 1.2 meters tall, casts a shadow of 1.8 meters. This is important. Cool. A wind turbine casts a shadow of 10 meters. How tall is the wind turbine? There you go. Well, figure out the scale factor and you got it. How many times bigger is 10 compared to 1.8? Divide. You could also be a proportion person and set it up. You could say it's 10 over 1.8. You could say it's 5.5555555. So 10 over 1.8 is the scale factor. I need to take 1.2 and multiply it by 10 over 1.8. This is Abbott. And we get 6 and 2/3. Look at that. Meters. Cool. Yo, this might get our video taken off of YouTube because we got music in the background. This will be interesting. Let's see. Blah 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 blah. You can't hear the music. You can't hear the music. You can't hear the music. I think it'll be fun. PQTRST 9 3 4. 3 times bigger. Right? 3 times bigger. What's RT? 3 squared plus 4 squared equals c squared because this is a right triangle. C squared equals 25. C equals 5. Times 3, 15. Times 3, 12. Why did I say this is 12? Oh, because it is. All right, well, This entire length is 12. What is this length? 8. Aha. There's other ways to do it. What's the ratios of the two sides of the triangles? Well, like times 3, 3 to 1, 3 to 1, whatever you want. So, I don't care. What about the areas? Aha. Areas. Well, you know that it's going to be times 9 because it's like the length factor, the scale factor squared. Could you double check this? Yes, you could. You could do 1/2 base times height of the big one. You could do 1/2 base times height of the small one. You could compare those two numbers. This is 6 times 9, which is 54. This is 2 times 3, which is 6. 6 times 9 is 54. So there you go. All right, another triangle inside of a triangle. Tanya is 1.3 meters tall. She stands 7 meters in front of the tree, casts a shadow of 1.8. How tall is the tree? Draw your triangles out. Because Tanya being 1.3 with her shadow of 1.8 means the height of the tree casts a shadow that would be 7 plus 1.8. 8.8. That's the thing everybody messes up on. They think it's 7. All right, let's find the scale factor. 8.8 divided by 1.8, and then multiply 1.0. Should be your calculator ready form. If you have a calculator, 8.8 divided by 1.8. You could also set up a proportion and solve if you wanted to, times 1.3. And you get 6.355. Is T. I forgot to write that the scale factor is 4.888. Okay. That is how many times bigger this triangle is to this triangle. All right, same one. Everything's kind of listed off for us. We got the small, the big. This is XBY. This is ABC. This is 12.5. This is 12.5 plus 7.5, which is 20. This is 3y minus 2. This is 3y minus 2 plus a y plus 2, which gives us 4y. Same thing. Let's just figure out the scale factor and then like kind of apply it. Or we can set up a proportion and solve. I will do both. 20 divided by 12.5 is how much bigger this triangle is compared to the other triangle. It's 1.6 times bigger. Cool. That means you could take 3y minus 2, multiply it by 1.6, and you'll get 4y. Or you could take 4y divided by 1.6 and get 3y minus 2. Or you could set up a proportion. It'll have decimals. It'll be gross. So I'm not going to do that. But you could set up a proportion, 20 over 12.5 equals 4y over 3y minus 2, and then cross multiply and divide, but then it'll be a lot of decimals. So I'm just going to go with this. I need 3 times 1.6 y's. The numbers will be easier on your quiz. This is more just 4.8 y's minus 3.2 equals 4y's. I will subtract 4y's. I will add 3.2 to both sides. And I will get 0.8y's equals 3.2. I'll divide both sides by 0.8 and I get y equals 4. Look at that. All right, you guys remember this stuff? Yeah, we're going to have this on your quiz. This is another star that you need to do. You also need to be able to find the location of A prime. Okay, that's good, good, good. All right, cool. So find the lengths of AB, BC, and AC. We might as well use our table. This is AB, and we can see we're adding 1 and we're adding 2. So that's an X distance and a Y distance. So AB squared equals 1 squared plus 2 squared. So that's 4, 5. AB is the square root of 5. BC, 3, 3 to 5, 2. We're going to add 2, subtract 1. Okay, look at that. Y's over X, the slope between A and B is 2 over 1. Let's look at that. BC, the slope of this line is negative 1 over 2. What do you notice about those slopes? Keep that in mind. Okay, well, let's look at the lengths. BC squared will equal 2 squared plus 1 squared. So BC is also going to be the root of 5. Let's look at AC. A is 2, 1. C is 5, 2. I'm going to add 3. I'm going to add 1. So I got AC squared equals 3 squared plus 1 squared. AC is going to be root 10. My cursor catches up. Cool. Is ABC a right triangle? Yes. Why? The slopes of these two line segments are opposite reciprocals, which means they must be perpendicular. Perpendicular lines means we must create a right angle. That's important. How else could it be true? AB is perpendicular to BC because the slope of AB equals 2 versus the slope of BC equals negative a half. Or let's use our lengths, AB squared plus BC squared. Does that equal AC squared? Well, yeah, root 5 squared plus root 5 squared equals root 10 squared, correct? Okay, ABC is scaled by a factor of 2 where the center of dilation is S. What are the locations of A prime, B prime, C prime? Okay, this is where we like take our guy and we like push our point further out. That will snap into a line, I hope, at some point. And we want to double the length. So we kind of want to continue along the path of this straight line. And what essentially happens is we just like apply our slope just for a longer time. Like we'll double things. Okay, so let's just look at here. We have S at 6, 3. We know we want to go down 1 over 1. We will just continue to go down 1 over 1. This would be a scale factor of 1, bringing it back to where it's located. Doubling that would be a scale factor of 2. So how will we do that with the points? We'll start with S, the center of dilation, which is the most important point. We'll have C, which is 5, 2. We understand that the slope is like down 1 over 1. Well, if I want to like double things to make this like twice as far as it started, I'll just continue to apply that slope. Or instead of subtracting 1, I'll subtract 2 from 6. So this becomes 4 and this becomes 1 if I just continue and I double things. If this was a scale factor of 1.5, what would that look like? Well, 6 to 5 is minus 1. That's a scale factor of 1. I would do another half of that and get to 4.5. Cool. If you had a scale factor of 3, we would just keep applying our slope. That if you had a scale factor of some crazy decimal, you would look at what your scale factor of 1 is and multiply it by the crazy decimal and then add that to S. But like, we'll keep it simple. So that's C prime. Let's look at B prime. Subtract 3, subtract 3. Subtract 0, subtract 0. So that's B prime. Scale factor of 1, scale factor of 2. Scale factor of 1, scale factor of 2. And let's go with A and A prime. Subtract 4, subtract 4. 2 minus 4 is negative 2. Subtract 2 would be negative 1. So there's the points C prime, B prime, A prime. How many times bigger is the perimeter of ABC compared to triangle ABC? You could spend a lot of time calculating the perimeter of your new triangle. You could look at A prime, B prime, C prime, and you could spend a lot of time being like, what is this length? Well, guys, you know what the length is. It's going to be doubled AB because you are scaling things by a factor of 2. So you don't need to do anything. You have all the answers already. So like, what about our perimeter? Well, like, if you know the perimeter of this, you just need to double it. That's it. If your lengths are doubled, your perimeter is doubled, you don't have to waste time doing a lot of work. You should just know the relationship. Could you double check? Sure. Would it be a waste of your time? Yes. All right, cool. And then like, how many times bigger is the area? Again, we could spend a lot of time doing like base times height divided by 2, and you'll have a lot of roots or decimals, but like, you know that if you took ABC, you scaled the lengths by a factor of 2, your areas are going to be scaled by a factor of 4. Why? Because it's units squared, okay? It's shading, not lengths. Okay, so that's it. Hope you understand this. We have a good quiz for you on Friday. So be ready for that newer triangle, but also be ready to understand scaling, to find lengths, to find areas, all that stuff. The real world situation that we did in class with the mirror, make sure you remember doing that because like that might show up on your quiz. Okay. All right. I'm out. Peace.